One huge application of calculus is that it gives us some techniques of working with a formula for a function to find the location and value of maxes and mins. Now, that's something that you'll be learning next semester in calculus. Quadratic functions are special. Quadratic functions are among the only ones that we work with on a regular basis where we can find whether a function has a max or a min, and we can find the location and value without calculus. And that's because the graph of a quadratic function is a parabola, and the vertex is going to be either a high point or a low point. So what I'm going to do is I've got 4 functions up here. For each one, we're going to first of all answer, do we have a max or a min? Then we're going to give the location of the max. That's going to be our x value. And we know that's the opposite of b over 2a. And then the value of the max or min, that's our y value. That's what we'll get by plugging into the function. Okay. Now, here I'm asking for location and value. Be aware that often you'll be asked for one but not both. Make sure you read the question and answer the appropriate question. All right, so if I look at f of x here, well, the squared term is negative. My a, the coefficient in front of x squared, is negative. I know that's going to open down. If it opens down, we've got a high point, so we're going to have a max. Okay. All right, now I'm going to just write down my a here was -3, my b was -5, and my c is 2. So the opposite of b over 2a, that's going to become +5 over 2 times -3. That's 5 over -6, or just -5/6. That's going to be the location of the maximum value for that particular function. Now, to find the value, I've got to plug that in. So, we'll have -3 times -5/6 squared minus 5 times -5/6 plus 2. So we square it first. So it's going to become 25 over 36. We're multiplying that by -3, which I'll write as -3 over 1. Okay. I'm going to write that -5 is -5 over 1. So this becomes plus 25/6 plus 2, which I'll write as 2 over 1. Now, I can cancel here. 3 is going to go into 36 12 times. So this becomes -25/12 plus 25/6. If I got a common denominator, that would be 50/12 plus this will be 24/12. So we'll have some 12ths. -25 plus 50 is +25, plus 24 is going to be 49. So the value would be 49/12. Okay. A little bit tedious when you have to plug in a fraction. Not the end of the world, but definitely something you want to be practicing before you encounter it on a timed exam or quiz. All right, let's do g of x together, and then I'll have you try the last 2 on your own. So for g of x, my squared term is positive, so that's a parabola that opens up. Well, if it opens up, we're going to have a min. Okay. All right, so to find it, I'm going to write down my a, my b, and my c. Let's erase the ones from the last problem so we don't confuse ourselves. A is 4, b is 0, and c is 3. Now, I don't really need c in this case, but I just want to point out b is always the coefficient in front of the x's. I don't have any x's, so b is 0. Okay. Remember, a can't be 0 or we wouldn't have any x squareds and it wouldn't be quadratic, but b or c is allowed to be 0. So the opposite of b over 2a, we're going to get the opposite of 0 over 8, but 0 over any non-zero number is just 0. So the location of the minimum, which would be the x value of our vertex, is 0. To get the value, we simply plug that in. But if I plug in 0, it kills off that first term, and we just get 3. All right. So at this point, pause the video, try working out these last 2. Again, just telling me whether we have a max or a min, and then finding the location and the value of those. All right, I've got the answers up here on the board. You'll notice I find it really helpful if my squared term is negative, I draw a parabola that opens down. That really helps me to see that I have a max. And if my squared term is positive, I draw a parabola that opens up, and that just helps me to see that I have a min. Okay. Now, I filled in the answers for the location and value of the max and min here. Over here, I showed my work for the first problem, and here I showed my work for the second problem. Okay. In both cases, I just used the formula, the opposite of b over 2a, to get the x value of the vertex, which is the location of the max or min, and then I plugged it in. What I'm going to do is I'm going to stop talking. I'm just going to leave this up here. If you got the correct answers, great, you're done. If not, you want to spend a little bit of time looking through that work, I'll leave this up just and stop talking so that you can check your work.